Okay, this is section 3, part B, and we're going to deal with growth and decay rates and growth and decay factor, which are related. So a growth rate is just a percent change. Could be positive, could be negative. It's called a growth or decay factor, depending on whether the quantity is increasing or decreasing. A growth or decay factor is a number that we use to grow something or to shrink something by a certain percentage. And we get it by right here, 1 plus or minus the percentage we're trying to grow or decrease something by. And so I'm going to give you a few examples of this so you can understand how to calculate a growth or decay factor and then how to use it. So here's the rates. This means I want to increase something by 20%. This means I want to increase a number or something by 5.4%. And this means I want to decrease a number by 12.3%. Now the question is, what do I multiply it by, which is called a factor, if I want to achieve these results? Now here's what you have to remember. It's really 1 plus or minus the percentage. It's minus if you're subtracting, if you're decreasing, like here, and it's positive if you're increasing. So this one is just 1 plus 20 over 100. I advise you to put that in your calculator, and you're going to get 1.20. So if you multiply something by 1.20, that'll increase it by 20%. Now here I'm going to increase it by 5.4%. 1 plus 5.4 over 100. And I strongly advise you to put it in your calculator. You're going to get 1.054. Now, if I want to decrease something by 12.3%, it's 1 minus 12.3 over 100. And if you put that in your calculator, you're going to get 0.877. So if you multiply something by 0.877, that has the net effect of decreasing the number by 12.3%. Now this one is obviously, I think you realize, you multiply something by 0.89, that's the factor. You're going to be decreasing the number. So you're going to have a negative, you're going to have a decrease. And one way to look at it is it's going to, well, I can see it's going to be 11%. If you can see that, that's good, because if you take 1 minus 11 over 100, you're going to get 0.89. Now this one, I'm going to look at it a little differently. I'm going to increase it by 1.25. That's 1 plus 25 over 100. The 1 comes from here, and then 25 over 100. So that really means that you're going to increase something by 25%. If you multiply it by 1.25. So let's take a problem here. It says a stock portfolio is valued at $20,000, decreased in value by 4.2% for 2 consecutive years, and then increased by 8% during the 3rd year. What was the value of the portfolio after 3 years? Now, to use this idea up here, down here, I'm going to need to know what I need to multiply the 20,000 by to decrease it by 4.2%. And then what do I need it to multiply this by to increase it by 8%? So for decreasing by 4.2%, I'm going to go 1 minus 4.2 over 100. guess I cannot. And that is going to equal, and that's going to equal 0.958. Now, if I want to increase something by 2%, by 8%, it's 1 plus 8 over 100, which is equal to 1.08. So now I'm ready really just to do the problem. So I'm going to take $20,000. I'm going to multiply it by 0.958. And then I'm going to or I could raise it to the second power because I got to do it twice, right? It lost 4.2% each year for 2 consecutive years. That's what consecutive means. Now I can do that. And that's going to give me the answer. Now the other thing I can do, and this relates now to exponential growth. You take 20,000 and I multiply it by 0.958 raised to the second power, right? Times 1.08. And that'll get me my answer that way. So really exponentials are nothing more than taking a number and increasing it or decreasing it by a certain percentage continuously. So we're going to look here at another way of how to use those factors in solving some problems that otherwise might be a little hard, okay? So in this one it says one reason for concern. We're looking at some numbers here. They're looking at 2005, we don't know what it was, and then it increased in 2006 by 3.2%. So anyhow, let's just, one reason for concern in this report is that incomes grew by 3.2% in 2016 and 5.2% in 2015, but only 1.8% in 2017. I'm going to work backwards here and find out, we know what the income, the median income was in 2016, that's right there. And we knew it grew by 3.2% from 2015. All right, so in 2015 it was lower than this. So this grew by 3.2% to become this. So there's a couple ways to do this. One thing you can't do is take 3.2% of this number and subtract it. The reason you can't do that because this number here is smaller. So you need 3.2% of this number increased to this. So I'm going to move this down and take a look at this. I'm going to do this. This is where it started. This is one way of doing it. So here is where it started. So that's the actual value of, it's 100% of itself. Over here, it's 1 plus R, which is 1 plus 3.2 over 100, which is 1.032. That's a 3% increase. So I'm going to set up a ratio here. And I'm going to put the ratio up here. Let me try to do it quickly. I have 100% there and 103.2% here. They're both percentages, so that's good. That's the factor there. And that's equal to the original amount, which is here, which I don't know, But this one here is 60,309. Now from here you can cross multiply and divide. And I'll put up the answer there in a second. Which becomes 58,439. So that's one way of doing this when you know that you don't know the original number, but you know the new number. But you know that the original number increased or decreased by a certain amount to get to the new number. Now, if you want to do it algebraically, I'll go through how to do it algebraically. Whoops. Back that up. So you have the original number, which I'm going to call X. If you increase that original number by 1 plus the rate, 1, which is this number here, you're going to get the new number. If you can do that, then of course you divide both sides by 1.032, and you're going to get 58,439. But you have to see that. That's tough. A lot of times it's just easier to set up a proportion. So let's do this one. So now we have 58,439. And I'm going to move it down here. And I'm going to do this one two ways, right? I'm going to do this one algebraically first. There's my original number. Which I don't know what it is. But if I increase it by 1 plus r, which is 1.052, that's the factor, I'm going to get 58,439. So this number here is smaller than this number here because this number here increased by 5.2% to become this number. So there's an algebraic way of looking at it. Now, obviously, you would divide both sides by 1.052 and you would get 55,550. That's the algebraic way of doing it. I'm going to try to back this up and we'll do it last part with the proportion. So here's how we can do this with the proportion. This is the starting amount, which is 100% of the amount. And then the amount went up by 5.2%. So I can call this here 105.2%, which would be here. Well, whatever. 105.2. It keeps doing the same thing, but that's good enough. So we will then, so here's our ratio. It's this to this is 100 to 105.2. So I'm going to put 100 to 105.2 equals, I don't know, to 58,439. So we end up with the same thing that we just did. You do it algebraically. But here I go from 100 to 105.2. That's a 5.2% increase over 100. So that's got to be the same as I don't know up to this increase. So there is the proportion, cross multiply and divide, and we get the same number.